Very good evening to the panel and everyone. We are Team Kinship from the Open University of Sri Lanka. In this presentation, our team will be discussing the selection and design criteria of rural bridges. This is the flow of our presentation. First, let's begin with identifying the word rural bridge and its importance. Any bridge that does not locate in a national road network is identified as a rural bridge. This means all the bridges located out from A, B, and E type roads are considered as rural bridges. Now let's look at the importance of rural bridges. These bridges are an essential component of Sri Lankan economy. They connect the country, support the network of product transportation, provide access to tourist destinations such as national parks, outdoor recreational activities, and scenic vacations. Our aim was to modernize the bridge system linked to road network to improve livelihoods of communities. The objectives were to identify bridge designs which can cater ever-increasing traffic loads in cost-effective and sustainable manner to fulfill the social and environmental needs. When designing rural bridges, following challenges were identified. Those were mobilization of construction material and equipment, ever-increasing traffic and loads, site and access constraints for construction, schedule, cost, and durability. Selecting material to overcome above challenges in two bridge types was exceptionally difficult. The selection of a suitable material for the vehicular bridge was the first challenge that we encountered. At the commencement of the design, we thought of using PVC together with reinforced concrete. That idea was rejected because of time constraints and the most of properties rely on workmanship. When using concrete, the dead load of the structure is very high compared with steel. Finally, we selected steel as our construction material. For the bridge with a longer span, suspended bridge was proposed, which is built using galvanized wire ropes, timber purlins, and planks. To conclude the most suitable design, we collected data from literature and resource people. A numerical model was developed using SAP 2000 to analyze compiled data.
Let's see how did we do our design. Before that, I would like to tell you what are the design considerations when we are going to do a design. We should think about strength of structure, safety of structure, durability of a structure, cost of a structure, and mobility. The bridges that we are going to build are in the rural area, so we have to consider lots of things. Examples, the construction methods, about the construction time and cost, about the access to the site and maintenance process. Considering those factors, we selected steel is the most suitable raw material for vehicular bridge. The reasons for selecting steel as main construction material are high strength to weight ratio, easiness to erect, attractiveness, easiness to mobilize the whole bridge as section. Here we used abundant steel roof trusses for our steel requirement. You know, in Sri Lanka there are lots of abundant buildings like school building, pavilions, government building, church. From them we can get steel. By using those material we can save money and we can keep our environment cleanly. After selecting material, we had to select more suitable and corrected method to join these trusses to final shapes. Normally, steel can be joined by welding and using nut and bolts, but we use nut and bolts to join steel members. Actually, by using nut and bolts, we don't want to extra plants and machinery like welding plant. Using bolt connection is much easier and simple. If we want to rearrange the structure, we can do it. Can maintain very easily, cheaper than welded joint. Then I'll briefly describe our main design steps of construction of vehicular bridge. First one is preparation of ground for substruction, construction of gabion walls. Here, as a abutment of a bridge, we use gabion walls. Then, by using nut and bolts, fixing steel members together in process. Third one, bridge deck preparation. For this, we used checker plate. Using checker plate, we can reduce weight of bridge and construction time also. Then fixing handrail. Finally, we decided to finish bridge with concrete in ground of besides of bridge entrance. These are the plan and elevation of our bridge. Selecting material for footbridge also is very important. Why those footbridge normally use only people, not for vehicles. So we decided to construct suspension bridge as a footbridge. We selected RC columns and cables for main load bearing members of this footbridge. We can get cables from tower cranes, and bridge deck was prepared by using kumbuk planks. Those planks also can be get from Sri Lanka Railway. Nowadays Sri Lanka Railway is removing all timber beam slippers and replace it using concrete slippers. Therefore, those remote slippers can be used for deck of bridge. Then I'll explain you how did we do our design of footbridge. First step is construction of anchor blocks, column and beams. Then fixing cables. Finally, fixing wooden slippers. I like to tell you about problems we encountered while designing these two bridges. For vehicular bridge, selecting suitable material for substructure and superstructure, using prefabricated steel members, selecting joining methods, preparing bridge deck by using checker plate. And also for footbridge, we always try to reduce unit weight of structure and construction cost. Innovations behind our design is selecting material for superstructure and substructure for vehicular bridge and footbridge. The main raw material is steel trusses for vehicular bridge. Steel trusses can be interconnected very quickly and easily. Steel is less affected by weather condition compared to timber. The elements can be lifted into position without using high capacity lifting equipment. Gabion walls are used as substructure. Using gabion walls is a very good solution as bridge abutments for rural areas. Because of high machinery-like bridges may not be operated while saving time and cost. A suspension bridge is proposed for footpath. It can be constructed by using timber used crane cables, RC concrete columns and beams. Generally, footpath does not use for vehicular traffic purpose, only used for pedestrian traffic. Due to this reason, we have decided to use cables and concrete columns beam as main load bearing members because of those materials are found very easily.
Okay, now let's focus about the numerical model design of our analysis. We develop it using SAP 2000 and SolidWorks. We analyze deflection pattern, critical positions, maximum compression and tension of the vehicular bridge. From that, we obtain the following results. Maximum failure compression force occur at the end support positions in vehicular bridge. From the load analysis, we see failure load can be reduced by reducing the weight of the bridge. Due to that, we introduce a checker plate to the bridge. Also, we change the support and condition as a pin and roller. Also, we introduce a double angle trusses and introduce 4 bottom girders to prevent it from lateral stability failure. In this video, you can see the prototype of our vehicular bridge, which is designed by SolidWorks.
When estimating the cost for vehicular load-bearing bridge, it cost nearly 2 million and suspension bridge cost nearly 0.8 million with prevailing market prices of material, machinery and labor. As our main target is to fulfill the requirement of a bridge at lowest cost, hereby we propose reusable construction materials. Usage of proposed reusable construction materials led us the way to reduce the cost. For an example, if we take measures to fulfill our class 1 timber requirement from market, it costs 200,000, and if we use sleepers for the same purpose, it costs only 26,000. This makes a saving of nearly 7 by 8 portion of the cost. So as well, we can fulfill our steel requirement, mainly angle line sections from abundant roof trusses removed from public places like schools and from abundant steel bridge sections for renovations. In public property auctions, steel is auctioned per weight, nearly half of market price. In purchasing cables removed from cranes and so also cost per weight. Thereby we can reduce the estimated construction cost nearly to a half. Usage of these reusable materials impact on environment and society also in a good manner. If we purchase class 1 timber from market, many valuable trees like kumbuk mee has to be fell off in any area of the country. This may support the present problem of deforestation and oxygen percentage reduction flowing over the country. In construction of these bridges, labor force may collected from villages and this make the way to villagers in enhancing their pocket. Also, these bridges make easy access to earning points for villagers. Our project proposal come across mainly on benefits and applications as easy assemble, short-term construction with low-cost margins. So, we are pleased to conclude that Kinship, from us to us, presents this economic steel bridge with cable-stayed suspension bridge for reliable, simple, strong and long-lasting bridge proposal. And also, we would like to make this a chance to pay our heartiest gratitude to engineer Mr. L.S.S. Vijayawardena, Senior Lecturer of Open University Civil Engineering Department, and Mr. Bandula Jayantha Venkappuli, Chief Supervisory Manager at Sri Lankan Railways, and all other well-wishers who were supportive in any means of our work so far. We have arrived to the end of our presentation and these are